So the last presentation is holding Kevin from SCION Association, and yeah, name is topic. He will present us what SCION does, how it works. Second. Yeah, okay, finally. So the stage is yours.
All right, thank you very much. So I realize we're a little bit behind time, and I realize that SCION is your path to the beer, but hopefully it's a secure path to the beer, as you may hear. Okay, so you may be aware, or you may not be aware, that Switzerland is the home of SCION. This is where it was invented and where it has been rolled out, probably, well, definitely more so than anywhere else in the world. So felt it was a good opportunity to come and talk about SCION. Some of you may have heard something about SCION. A lot of people have heard about SCION, but some people have some misapprehensions about SCION. Some of people are actually quite keen on SCION as well. But hopefully this will go through and just give some sort of insights and maybe dispel some myths about SCION as we go along. So earlier somebody did a poll of how many SREs there are and how many network engineers there are in the room, and I think this is a pretty technical audience, so I don't really need to explain how the BGP works and the global routing system. But just to sort of set the scene, that there's, as of last week, there was over 76,000 autonomous systems that were publicly visible on the internet, and there were just over 980,000 IP prefixes. That diagram was produced, it's sort of an attempted mapping of the internet based on logical paths, kind of sort of geographical based as well, but it's a little bit out of date now. They haven't done an updated version, but it's there to sort of illustrate really all the, the sort of sheer mesh that exists on the internet, and the fact that there's like really a lot of paths that can go anywhere. And as you probably know, the BGP is inherently based on unverified trust, and it doesn't have any built-in validation that route advertisements are legitimate. So what this means is that any network, effectively any network, can announce any ASN or any IP prefix and essentially masquerade as another network. Okay, there are things that we can do, as we will see, but that's sort of the base protocol. The other issue with BGP is that sending and receiving networks cannot easily decide on the path that the intermediate routers direct the traffic across the internet, and that's by design, because that's how the protocol was designed. I mean, there are things you can do, but that's the sort of basic premise. Okay, so why is this a problem? Well, there's sort of kind of three main problems. One is a route leak. So this is a kind of accidental misconfiguration, so that your traffic is going through an unintended path. And this can cause delays, and it can cause intermediate networks to carry unintended traffic. There's been some spectacular incidents of this. Back in 2019, Verizon kind of accidentally DDoSed a small service provider in, I think it was Pennsylvania. But this is not an uncommon occurrence on the internet. Perhaps more seriously is a route or prefix hijack. So this is where a network operator or an attacker is actively impersonating another network operator by sort of announcing false ownership of prefixes or ASNs. Traffic is going to the wrong place. This is frequently used for DDoS denial of service attacks. It's also a traffic interception, but it can also be used for censorship. It's been actively used for censorship by some countries as well. This can kind of spin out of control and cause quite large problems. You've probably heard of the major incidents, but this is happening every single day on the internet. I used to sort of monitor this, and there was numerous incidents every single day happening. So the other kind of issue, which is perhaps less thought about sometimes, is that BGP can send, often does send traffic across geopolitical boundaries. So this is becoming more of an issue as people are thinking more about things like data protection and GDPR. And then you've also got this NIS2 directive coming in, and it doesn't kind of go into too much detail about routing security, but it is mentioned in there. So, this could become an increasing issue, in the future, from sort of a legal perspective or a regulatory perspective. And there was it's a bit difficult to get really good incidents or find out about really good incidents, but there was an incident last year where an Australian healthcare provider in the Northern Territory tried to send some data to Sydney. This went through a third country, which it shouldn't have done. So that was a clear breach of healthcare data protection regulations. So again, this causes all kinds of regulatory concerns and makes regulatory compliance complex. I mean, perhaps the regulators haven't completely caught up with this yet, but I think this will come along in the very near future if it hasn't already. Okay, so how can this be addressed? So I guess a lot of people would know about RPKI. So this is the cryptographic assertions that the IP prefixes that you're advertising or your ASNs that you're advertising, you can cryptographically assert that you're authorized to do that. You can then implement route origin validation. But at the moment, it's actually now over 50% of IP prefixes are actually, they have ROAs created. It's just over 50%, I should say. But actually very few operators are actually doing ROV, so route origin validation. It's just over 5%. And of course, this is only doing origin validation. It's not actually validating the path through the network. So, and bear in mind, this has been going on. I think RPKI became a thing about 2008. So there's been quite a few years that this has been rolled out now. So it's kind of also realized many years ago that it isn't just enough to use RPKI. You might also want to authorize the route that your data is taking or your packets are taking. So BGPSEC came along. I think it is actually formally an IETF standard, but it's not very well or at all supported on the internet at the moment. It really needs to be explicitly supported by all the routers on a path. The argument about it being computationally intensive is perhaps less so today. It may be almost an irrelevance, but it does have introduced some delays in route convergence. And even then, explicit path selection is still not possible. So we have this intermediate sort of approach called ASPA. My former colleague and also the SwiNOG organizer, Max, is involved in this. So this is really a kind of out-of-band path authorization. So this authorizes other ASNs to carry traffic through the internet. We have slight disagreements on whether this is a sort of stopgap technology, but okay, the fact is that this is still not fully implemented, and it still has the same problems of BGPSEC, or some of the problems of BGPSEC. So this is where SCION comes in. So we can actually, with this, provide an inter-domain routing architecture that does provide this sort of secure path awareness and enables you to select your path across the internet, at least the SCION-enabled part of the internet. There are issues that we need to support that with border routers, and I will go into some of the more of the details of that. Okay, but why would we introduce something that needs specific hardware or specific software? Well, actually, there are actually quite a lot of critical infrastructures out there that are running on really, really legacy infrastructures. Some of these are actually, in some cases, not actual networks. They're things like the telephone system. And others are not IP-based. They're running on some kind of serial protocol. Air traffic control system is one of them. And this is just becoming really expensive. It needs point-to-point links. There isn't a lot of resilience in this. As this equipment is aging, and there's actually support personnel are aging, it's becoming more difficult to support these infrastructures. So there's quite a number of organizations like the air traffic control system, like the power utilities, and a number of others. Defense is another one. They're actually saying, okay, maybe we can just move to the commodity internet. We can actually, it's reliable enough and sufficiently cheap enough that we can actually sort of take the risk of using it. It's not a risk, but it's a calculated risk. But we do need to have, and there's cost advantages of doing that, and there's resilience advantages. But actually, we do need to have higher trust and data sovereignty assurances than what the internet can provide today. So that's kind of what's been stopping this. And these industries work on really long cycles, like 10-year, 20-year cycles. So this is a long, long process, but they are in this process of saying we've got to replace a lot of this stuff now. So yes, there are things that you can do with the internet now, the sort of MPLS type of approaches. There's SD-WAN, but the sort of true interdomain multi-ISP support is actually quite desirable for a lot of these organizations, particularly ones that cross international borders, like air traffic control. So that sort of gives you the sort of background of perhaps the appeal or the attraction of SCION. Okay, so what is it? So it's it's an interdomain multipath routing system at its core, and it can work with. It has a number of positive features. One being it has quite fast path failover. It can work with multiple operators. But one of the really strong things is that it has path control. So source endpoints can actually select the path through the internet, and you can actually assign policy to the paths that you want to use. So there is that sort of higher assurance. You've still got the layer 2 issues that you need to think about, but there are higher assurances that your packets will follow certain paths, which means that you have more protection against hijacking, but particularly you can do geofencing as well. Okay, so the model around here, the sort of model around how SCION works, works around something called an isolation domain. Probably with hindsight, it wouldn't have been called an isolation domain. It's a trust domain, but that's the terminology that was picked. So the isolation domain is a logical grouping of autonomous systems. But they self-administer. So there's a sort of group of what they call voting ASs, which are the sort of usually the founding ASs, and they administer the ISD. They can add additional voting ASs, but there's also you can add other ASs as well. But this is governed by something called the trust root configuration, which is essentially a meta X509 certificate. So that provides the trust root that's distributed. So the trust root is controlled entirely by the trust domain, by the core ASs. So you're not reliant on the global CA system either. You run your own CA. Then you have a couple of other elements to this. So on the control plane, you have a thing called a beacon server that sets up what they call path segment construction beacons, which sort of works out, which AS is connected to which AS, and that sort of builds up a database of segments that then allows paths to be built from these segments. So this database gets built with all the sort of potential routes potential paths across the sort of SCION-enabled internet. So initially it's been the trust domain, but you can also do this between ISDs as well. And this is authenticated with your PKI as well. So although these are sort of beacon server and path server are technically separate elements, this is usually a control box. It's a control service box, or it can be on in a container. It can run on a VM type situation. Then with the data plane, this is combining these path segments into these end-to-end paths. This gets sent with a SCION packet. It's essentially the address is a combination of the ISD and the AS. You can use actually public ASs. You don't have to. You can use private ASs as well. But that's a combination of. So the ISD is a unique identifier, which is currently there's a registry that the SCION Association will be taking over. But that's where you get that unique identifier from. And then you have border routers that will forward the packets from one SCION router to the next. Okay, so the border router. So the AS, you can just run your intra-domain protocols. You then have one or more SCION routers that are set up, so SCION-enabled routers that are set up at the borders of an AS. And these pair with other SCION-enabled networks and that collect the customer traffic. So again, I talked about the control services. This is the element that discovers and maps the network paths. So you don't need to change the internal network infrastructure. You can run a SCION stack on the endpoints. This is not very common at the moment. So we tend to, the implementations tend to use something called a SCION gateway. So just legacy, as in regular, systems, can go through these SCION gateways, which will direct your traffic across the SCION part of the internet, and then at the other end, it will sort of decapsulate and forward it on. So, so ultimately, where we want to get to is, that you'll have operating systems or devices will run SCION natively or be part of their stack, networking stack, and they can just connect into this directly. Okay, so one of the other benefits is the multi-path discovery. So, BGP will generally select routes based on the lowest cost, regardless of whether these are necessarily the most optimal, or particularly whether they meet perhaps particular requirements, and geofencing is one of them. But you can also add things like sort of environmental policy, a number of other things as well. So because this beaconing is built up in advance, it doesn't rely on iterative convergence. So you can quickly switch paths, and you can quickly use multiple paths within 1 or 2 seconds. So that's proven to be a sort of real world calculation. So ultimately, the idea is that your applications can choose a path based on particular optimal characteristics. Okay, so that's the theory. What about the practice? So this does have a real-world deployment. So you may have heard of the Secure Swiss Finance Network. So this has been set up by SwissIX, the Swiss financial infrastructure operator. And one of the reasons they moved to this is they originally had a pre-existing network. This was kind of getting expensive to run, and a number of other issues. So one of the things they wanted to sort of move more to a commodity internet approach, but they also wanted some enforceable governance. They wanted sort of higher levels of trust. The performance routing is also quite important. Financial transactions, you need it to be reliable. It's not a huge amount of data, but it does need to be reasonably timely, and it needs to be quite reliable. So, and the other reason they went towards this was because they wanted this to work with multiple ISPs. So this is supported by Sunrise, with Swisscom, Cyberlink, Switch as well. I think was a very early one. So there's 4 providers at the moment. Okay, so there were some lessons learned. It hasn't been smooth sailing, as you'd imagine. There have been a number of issues, as with anything that's new and being rolled out for the first time. It's also sort of kind of largely been around the actual human networking side, so the sort of administration of the ISD and the trust domain. There have been sort of issues around the certificate revocation, the management of the PKI system, and we sort of discovered that some of the SCION routers and some of the SCION products aren't fully featured. There was a particular problem with some packet throttling, which is very easy to fix, but ran into that problem early on. And perhaps the sort of current limitation is that the inter-ISD paths, that control is not fully featured yet. That will come, but certainly within an ISD, within a ISD domain, you will have that at the moment. But it has been reliable, the path failover, so that has been typically within 1 or 2 seconds. That is one of the the postulated benefits that has been proven. So beyond finance, you've got the HIN Trust Circle. This is the Swiss healthcare network. So they connect hospitals and doctors. It's been quite challenging connecting the sort of surgeries, doctor surgeries. A lot of them are running through the gateway system, but that's kind of quite far into the rollout process now. That should have been deployed by now. I think it will be deployed fairly soon. For quite some time, you've had the SCION Education and Research Network called Sierra. Actually, this has connections to other parts of the world as well, Korea and Singapore, I think Brazil, also in the US as well. So a lot of the the stuff is tested on that, and actually you can actually participate in that as well if you're sort of interested. And we're at the moment talking to the Swiss electricity companies. That's another sort of fairly advanced use case. It is supported by SwissIX. I think there was someone from SwissIX who actually gave a talk. So they were the first IX to support SCION. Familiar players there. And then, okay, so in terms of, what are the implementations? So at the moment, there is a commercial implementation produced by an company called ANAPAIA. They're based in Zurich. The Swiss Secure Swiss Financial Network, SSFN, is based on ANAPAIA equipment. I think the HIN is also. But there is also an open source version. This is maintained by the SCION Association, who I worked for. So we're working on that, implementing new features on that, supporting that open source software. So just to mention the SCION Association, so this was formed by a number of deployers and early adopters really to support not just the open source development, but it's also to work on the standardization process, which I'll talk about in a second, and also really try to sort of promote adoption of SCION, not just in Switzerland, but also internationally as well. There have been other experimental implementations like on OpenWRT, and there's sort of been experiments with P4 as well. Okay, so what we're trying to do is, we're not trying to break the internet here. So actually we're pushing this through the IETF at the moment, because actually this is really important for standardization and for future interoperability, because we do want to have alternative implementations, not just ANAPAIA, and we actually would like this to be adopted by other vendors. And in fact, we have been talking to 2 or 3 other quite well-known vendors who are reasonably serious about supporting this, largely because they have customers in Switzerland that are asking for this. So, there's a number of ISPs that have been asking for this support in, sort of, shall we say, well-known routers. The other thing is that when you go out to, particularly for these sort of big procurements, like particularly for these sort of big critical infrastructure procurements, which are on these 10-year cycles, having a standard, having something backed by a standard is really important. You're much more likely to be accepted, or much more likely to be considered to be a credible candidate if you have some standard backing this. So we're actually going through documenting this through the IETF process. Well, technically it's IRTF, but okay, that's a sort of distinction they meet at the IETF. Through the PANAG Path Aware Network Research Group. We've also picked up some interest from some other IETF working groups, but we have submitted the sort of core specification to the independent submission stream at the IETF. There's actually 3 active drafts. There is a sort of general overview one that's going to expire. We won't renew that. We've incorporated that into the other drafts. And we've most recently been working on a new draft around the deployment issues. There's not really a readable version at the moment, but that's sort of on its way. So this is sort of, we're trying to play nice and get this to work with sort of other sort of with the sort of general internet ecosystem. Okay, so just to mention here, so I've already mentioned the SCION Association, but there is there's quite a big network of users. Vendors that are working with this, potential vendors that are working with or actively working on implementations. I do want to mention there will be something, we're having our annual SCION Day, which will be on the 22nd of October in Zurich. You're quite welcome to come along to that. I think there's going to be already 300 registrations for that. I know there's also people from the Netherlands in here. Actually, outside of Switzerland, the Netherlands has actually got a reasonable amount of interest, and we're looking to hold a sort of mini SCION Day in the Netherlands in November. We haven't quite fixed the date yet, but if you're interested in that, I can sort of send the details. We've got to find out, got to define the details for that. But we're sort of, yeah, that's the plan, because we try to sort of raise some awareness of SCION there as well. And that was my last one, which I hopefully is just in time for the beers. Just to mention, there's some links there to various documentation. There is a book which sort of is kind of the original specification. It kind of explains most of the technical details in that, so that's available. But yeah, if you have any follow-up questions, I don't know if we've got time for any, but I'll be around for a bit, so just come and find me and I'll try and answer them. And that's everything from me.
Thank you very much, Kevin. Thank you.
Okay.
Questions?
No, well, if there's any, I mean, if you've got
There's
time.
like a burning question. We have time for one. No,
I think people
guess
want beer. Yeah, that's understandable. That's perfectly understandable.
Yeah, okay.
All right.
Thank you very much.